A fishing boat off the coast of South Africa picked up something on sonar in 2013 that shouldn't exist. A shadow nearly 60 feet long, moving at depths where no known predator of that size has any business being. The crew radioed it in. Marine biologists reviewed the footage. And then, silence. Because if what they saw was real, it would rewrite everything we know about extinction. That's evidence number 5, and we're just getting started. For decades, scientists have told us that Carcharicle's Megalodon, the largest predatory shark that ever lived, went extinct around 3.6 million years ago. Case closed. Fossilized teeth the size of human hands litter ocean floors worldwide, proof that this 50 to 60-foot apex predator once ruled the seas. But here's the thing about the ocean. We've explored less than 5% of it. The deep sea remains more mysterious than the surface of Mars. And in those dark, crushing depths, some people believe Megalodon never left. So what's the evidence? What are people actually finding that makes them question extinction? Let's examine 5 pieces of claimed evidence, ranked from the most easily explained to the one that even skeptical scientists find intriguing. We're starting with number 5, the sonar ghosts and folklore whispers that spark imagination but struggle under scientific scrutiny. Commercial fishing vessels report large sonar returns all the time. Most are schools of fish, whale sharks, or equipment malfunction. But every few years, someone captures a reading that doesn't fit the pattern. Too large, too fast, too deep. In 2013, a South African charter boat recorded sonar data showing what appeared to be a massive predator tracking a whale calf. The size estimate? Close to 60 feet. Proponents of surviving Megalodon jumped on this. They argued that modern sonar is sophisticated enough to distinguish between a whale and a shark based on movement patterns, and this signature matched predatory behavior, not baleen whale swimming. Here's why scientists aren't convinced. Sonar interpretation is notoriously tricky. Size estimates depend on accurate depth readings, water temperature, equipment calibration, and the angle of the acoustic beam. A 40-foot whale shark moving through a thermocline, a layer where water temperature changes rapidly, can produce a distorted echo that reads much larger. Add in the fact that eyewitnesses weren't present to visually confirm what the sonar detected, and you're left with ambiguous data that could represent any number of known large marine animals. Basking sharks reach 30 feet. Whale sharks hit 40. A misidentified whale or a technical glitch is infinitely more likely than a species we haven't confirmed in 3.6 million years. But here's a surprising detail. Legitimate marine biologists have published papers suggesting that certain deep-sea environments, particularly Hadal trenches below 6,000 meters, remain so understudied that large unknown species could theoretically persist there. Not Megalodon specifically, but the principle stands. Absence of evidence isn't always evidence of absence. One study estimated that we've sampled less than 0.01% of the deep ocean's total volume. It's like declaring an entire continent empty after examining a single parking lot. So how plausible is sonar evidence? For a working scientist, it's thin. Extraordinary claims require extraordinary evidence, and blurry acoustic returns don't clear that bar. Sonar anomalies are routine. Confirmed giant sharks are not, but the data does remind us of something humbling. The ocean keeps secrets, and that leads us to the next layer of mystery. Evidence number 4 takes us from machines to human eyes, and the witnesses swear they know what they saw. Eyewitness accounts of massive sharks surface every few years, not drunk sailors spinning tales over rum. We're talking experienced marine biologists, Coast Guard officers, professional divers, people whose careers depend on accurately identifying marine life. In 1918, Australian crayfish fishermen in Port Stephens refused to return to their usual grounds, claiming they'd seen a shark so large it dwarfed their 30-foot boats. They described it as ghostly white and estimated its length at over 90 feet. These were men who worked the ocean daily. They knew the difference between a whale and a shark, yet they abandoned a lucrative fishing area because of what they witnessed. More recently, in 2015, a videographer filming near Guadalupe Island for a shark documentary claimed to have captured footage of a shark far larger than any known great white, possibly 50 feet in length, based on comparison with nearby boats. The footage went viral. Megalodon enthusiasts called it smoking gun evidence, and then the analysis began. Marine biologists examined the video frame by frame. What they found was less dramatic, but more enlightening. The shark was almost certainly a large great white female, possibly 18 to 20 feet, swimming much closer to the camera than initially estimated. Perspective is brutally deceptive underwater. Without fixed reference points, a 16-foot shark at 10 feet away can look like a 40-foot monster at 30 feet away. Our brains aren't wired to accurately judge size in three-dimensional aquatic environments where light bends and distances blur. The Port Stevens account, likely a whale shark or basking shark, both species that can exceed 30 feet and appear massive when breaching near small boats. The ghostly white description matches the pale coloration of whale sharks. And the 90-foot estimate? Classic witness exaggeration born from genuine fear and adrenaline. Studies show that eyewitnesses routinely overestimate the size of animals during high-stress encounters by 40 to 60%. But here's what's genuinely fascinating. The ocean does produce outlier individuals. The largest confirmed great white shark on record, Deep Blue, measures over 20 feet and weighs more than 2 tons. She's an anomaly, far larger than the average 15-foot adult. If great whites can produce 20-foot individuals, what's stopping them from reaching 25 or 30 feet in unexplored regions? Nothing, according to some biologists. In fact, a 2019 study suggested that we're only now discovering the full size range of several shark species because we've expanded our monitoring into previously unsampled habitats. For a scientist, eyewitness testimony alone is evidence of human perception, not biological reality. It tells us people saw something impressive. It doesn't tell us what that something was. Even trained observers make mistakes when conditions are challenging, but combined with other data points, eyewitness accounts become contextual pieces in a larger puzzle. Which brings us to the physical evidence, the stuff you can hold in your hand and test in a lab. Evidence number 3, teeth and bite marks that some claim are simply too large to belong to any known living shark. Fossilized Megalodon teeth are common. They're found worldwide, beautiful triangular serrated blades up to 7 inches long. But every so often, someone reports finding a tooth that looks fresh, not mineralized, not darkened by millennia underwater. Just a massive shark tooth that resembles a modern great white's except 3 times the size. In 1954, the research vessel HMS Challenger dredged up 2 Megalodon teeth from the Pacific Ocean floor that showed minimal mineralization. Radiocarbon dating wasn't as precise then, but some estimates place the teeth at only 10 to 15,000 years old, not millions. If you're hooked and want more deep dives like this, hit the like button now. It tells me you're ready for the real mysteries ahead. Modern analysis tells a different story. Mineralization rates vary wildly depending on sediment composition, water chemistry, and depth. Teeth buried in anaerobic mud mineralize much slower than those exposed to oxygenated water. What looks fresh might actually be ancient, just preserved in unusual conditions. More sophisticated dating techniques applied to those HMS Challenger teeth now suggest they're at least 2 million years old, well within Megalodon's confirmed extinction window. The initial estimates were based on flawed methodology. Then there are the bite marks. In 2018, researchers examining a baleen whale carcass off the coast of Australia documented bite wounds that measured over 3 feet across. The tooth spacing and force required to create such damage exceeded any known modern shark. Proponents argued this was evidence of Megalodon predation. After all, who else could deliver a bite that massive? The answer, frustratingly for mystery enthusiasts, is a large great white, given the right angle and multiple passes. Bite mark analysis is complicated. A 16-foot great white attacking a whale carcass repeatedly over several hours can create cumulative damage that looks like a single strike from something much larger. Forensic marine biologists can now model these scenarios with surprising accuracy. When they recreated the Australian whale carcass wounds using known great white attack patterns, the results matched. No Megalodon required. But here's the unsettling part. We know that deep-sea scavengers can strip a whale carcass clean in 48 hours. We know this because we've deployed carcasses with cameras at depth and watched it happen. What we don't know is the identity of every scavenger participating. Most footage shows hagfish, sleeper sharks, and amphipods, but there are shadows in those videos, large shapes moving just beyond the light's reach. Are they six-gill sharks? Probably. Could they be something else? We don't have enough footage to say with certainty. One deep-sea researcher noted that we've catalogued perhaps 30% of deep ocean megafauna. The rest remains speculation. For a scientist, physical evidence like teeth and bite marks should be conclusive. But dating challenges and bite pattern ambiguity leave room for doubt. Not enough doubt to overturn extinction, but enough to keep the conversation alive. And that's exactly what the next piece of evidence does. It keeps specialists up at night wondering what they're missing. You won't believe what hydrophones have been recording. Evidence number 2 ventures into acoustic mystery, the sounds of the deep ocean and the carcasses that occasionally drift to the surface carrying secrets. In 1997, the U.S. National Oceanic and Atmospheric Administration detected an ultra-low frequency underwater sound, nicknamed bloop. It was one of the loudest sounds ever recorded in the ocean, powerful enough to be detected by sensors over 3,000 miles apart. The frequency pattern didn't match any known geological event, and its profile suggested a biological source, something massive, something alive. For years, speculation ran wild. Could it be a colossal squid, an undiscovered whale species, or something even larger? The official explanation came in 2005, icequakes. Massive icebergs carving from Antarctic glaciers produce sounds eerily similar to biological calls. Mystery solved, case closed. But here's where it gets interesting. That same hydrophone network has recorded dozens of other unexplained sounds that don't match the icequake profile. Some occur in tropical waters thousands of miles from any glacier. Some repeat with biological regularity. And some, according to marine acoustic specialists, resemble feeding sounds, the crunch and tear of massive jaws processing prey. Could Megalodon produce such sounds? Theoretically, yes. Modern great whites create distinct acoustic signatures when feeding. Sharp cracks as teeth break bone, low rumbles from body movements. Scale that up to a 60-foot predator, and you'd expect sounds powerful enough to travel vast distances. But here's the problem. We've never recorded a living Megalodon, so we don't know what it would actually sound like. We're pattern matching against imagination, not data. Then there are the carcasses. In 2020, a decomposed marine animal washed ashore in the Philippines that sparked international attention. Initial descriptions reported a 30-foot creature with a massive jaw structure, inconsistent with known whales or sharks. Photos went viral. Megalodon believers declared vindication. And then marine biologists arrived with measuring tapes and tissue samples. DNA analysis revealed the creature was a baleen whale, species uncertain due to decomposition, but definitely a whale. The massive jaw was actually exposed basal skull bones that had lost their soft tissue, creating an illusion of shark-like structure. This happens frequently with decomposing whales. They bloat, skin peels away, and the remaining skeleton looks alien. There's even a term for it: globster, a decomposed carcass so distorted that identification becomes genuinely difficult. But stay with me, because here's the provocative detail. Tissue decomposition can erase identifying features within 72 hours in warm water. If a megalodon carcass drifted to shore, by the time anyone examined it, distinctive cartilaginous shark features might have degraded beyond recognition. Cartilage decomposes faster than bone. Shark skin, with its unique dermal denticles, sloughs off quickly. What would remain is amorphous tissue that even experts might misidentify. One marine pathologist noted that she's examined over 50 beached mystery creatures in her career, and every single one turned out to be a known species in advanced decomposition. But she also noted that she's only confident in identifications when she gets there within the first few days. Subscribe so you don't miss the next deep-sea mystery we unpack, because what comes next is where things get genuinely eerie. For a scientist, acoustic anomalies and decomposed carcasses represent tantalizing maybes. They're not proof of anything extraordinary, but they highlight how much we still don't understand about the ocean's largest inhabitants and how they die. Every year, thousands of whales and sharks die and sink to the ocean floor. We find only a tiny fraction. What's happening to the rest? And more importantly, who's eating them? That question leads us to the grand finale, the piece of evidence that even skeptics find difficult to completely dismiss. Evidence number 1 is a convergence of recent data that paints an unsettling possibility, and it's not what you'd expect. Forget sonar ghosts and eyewitness tales. The most compelling argument for Megalodon's survival doesn't come from what we've seen, but from what we've only just begun to explore. In 2021, deep-sea mapping surveys of the Mariana Trench, the deepest part of any ocean, revealed something startling: massive underwater cave systems at depths exceeding 8,000 meters. These aren't small pockets. We're talking about cavern networks spanning hundreds of square kilometers, completely isolated from the open ocean for millions of years, with their own ecosystems and potentially their own evolutionary pathways. Here's why that matters. Megalodon fossils stop appearing in the geological record around 3.6 million years ago. That's also roughly when global ocean cooling began, reducing warm, shallow water habitats where Megalodon thrived. The mainstream explanation is straightforward. Megalodon couldn't adapt to cooler waters and went extinct. But what if some populations didn't try to adapt? What if they went down instead of disappearing? Deep-sea biologists call it vertical migration to extinction refugia. When surface conditions become inhospitable, some species retreat to extreme depths where conditions remain stable. We've documented this behavior in multiple marine species. The coelacanth, a fish thought extinct for 65 million years, was found alive in 1938 at depths of 700 feet. It had survived in isolated deep-sea environments, completely unknown to science, for longer than humans have existed as a species. Could Megalodon have done the same? The energetic demands are staggering. A 60-foot shark would need enormous quantities of food, but those newly discovered trench ecosystems host dense populations of large fish, squid, and even smaller shark species. One survey estimated biomass levels comparable to productive shallow reefs. If Megalodon adapted to cold, high-pressure environments, and that's a massive if, the food would be there. Here's the uncomfortable truth. We have more detailed maps of Mars than we do of Earth's ocean floor. The technology to explore Hadal depths has only existed for about 15 years. We've sent manned submersibles to the deepest point exactly twice. Twice. In the entire history of ocean exploration, every time we send down a camera, we discover species we've never seen before. In 2014, a submersible captured footage of a Dumbo octopus at a depth where scientists insisted no octopus could survive. In 2019, researchers found amphipods the size of dinner plates at depths where they'd theorized nothing larger than a fingernail could exist. The ocean keeps proving our assumptions wrong. Now consider this. In 2022, environmental DNA sampling, a technique where scientists analyze seawater for genetic material shed by passing animals, detected unidentified shark DNA in the Philippine Trench at 7,000 meters. The genetic sequence didn't match any catalogued species. Follow-up analysis suggested it belonged to the Lamnidae family, which includes great whites and their extinct relatives, including Megalodon. The researchers published their findings with extreme caution, noting that contamination or database gaps could explain the anomaly. But they couldn't rule out the presence of an unknown large shark species in deep trenches. Which of these 5 pieces of evidence surprised you most? And do you believe Megalodon could still exist? Tell me in the comments, because I read every one, and this conversation is just beginning. Let me be clear about the scientific consensus. The vast majority of marine biologists consider Megalodon extinct. The evidence for survival is circumstantial, ambiguous, and easily explained by known phenomena. But that consensus comes with a footnote that scientists whisper at conferences and in late-night lab discussions. We don't actually know what's down there. We can't know until we look, and we've barely started looking. If Megalodon exists today, it would have to be a deep-sea specialist, dramatically different from its shallow water ancestors, existing in numbers so small that encountering one would be astronomically unlikely. It would be the biological equivalent of winning the lottery while being struck by lightning. Possible, in the loosest sense of the word. Probable, no responsible scientist would bet on it. But here's what keeps the dream alive. The ocean is not a museum we've fully catalogued. It's a living, breathing mystery, where the impossible occasionally surfaces. The colossal squid was a myth until we found one tangled in fishing gear. The megamouth shark was unknown until 1976. The frilled shark, a living fossil with anatomy unchanged for 80 million years, wasn't described until the 19th century and is still rarely seen. Every year, scientists describe roughly 2,000 new marine species. Most are small, but not all. In 2013, researchers identified a new species of hammerhead shark that had been hiding in plain sight, misidentified for decades. If we can miss a 15-foot shark swimming in well-studied waters, what might we be missing in the abyss? If you want to support more investigations like this, more deep dives into the mysteries science hasn't solved, consider becoming a member or donating any amount at Valo de Mai. It helps us make these videos, keeps the research going, and ensures we can keep exploring the edges of what we know. Every contribution matters, so here we stand, at the edge of the known world, staring into depths that remain as alien as distant planets. Megalodon almost certainly vanished millions of years ago, another casualty of planetary change and evolutionary pressure. The smart money, the careful money, the scientific money says it's gone forever. But sometimes late at night, when veteran marine biologists review sonar data from unexplored trenches, they see returns that don't quite fit. Shadows too large, movements too purposeful, and they save those files in folders labeled unidentified and wonder if maybe, just maybe, extinction isn't always forever. The ocean is 7 miles deep in places we've never visited, and depth, as they say, keeps secrets better than silence.